And good news, on the next page, guess what? The students get to do it.
Whoa, that's so exciting.
So they should pause right now, and they should figure out which of those curves. See, if they had already paused, they wouldn't hear this part. That'd be fun. But they should figure out which curves match.
So you're saying that now that you've told them that, they should pause right meow.
Yes, and if they haven't, then we'll put an Edpuzzle question in. That'll make him stop. But now our job is just to circle the ones that look like they could be that.
Yeah, I'm also going to move this a little bit because, you know, just for funsies.
That's how you
I'm
roll.
going to start at the bottom. You want to start at the top?
I didn't even know there was a bottom, but sounds good. Oh, you're on that one. I was looking at the other page. Oopsies. Yes, I'll start at the top. Sounds good. There we go. Nope. Hate that one. Nope. 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 88 over 16 is some sort of positive. Sure, that'll be negative. I'm not doing all that work like we did last time.
Yep. Nope.
Okay, next one. And even better news, this is when they do on that themselves and they ask questions about it in class.
That's fantastic. This is going to be a great one for us to talk about in class.
Now we got to consider the two functions from question one. Identify the form. Oh, I can do that. So this is, they call it intercept form. Intercept.
They call it intercept or they call it factored form here?
Oh, did they call it factored? I apologize. I couldn't remember. Factored form.
We do often call this intercept or factored form. And depending on what you're reading, sometimes it's called one or the other.
That's true. And then this next one is vertex form. That one I remember. And write the function in the two other forms if possible.
So I'm just going to write standard form up here since that's the one we don't have. Oh, and I see that you're doing some double distribution to multiply that out.
Yes, and I got the 5 because you're going to get a 4x and then a 1x.
Cool.
So
and now
standard form.
And now you're then distributing again that -2 to each of those numbers to get your final answer.
Yes.
I like it.
And I don't know that we know how to get to vertex form yet.
We don't. We haven't seen that yet.
So I think we won't spend time on that. But one way you could do it is if you know the zeros from the original function in the factored form, the vertex has got to be halfway in between. So you could kind of fake your way into it. But I think right now, I think we're going to leave that where it is.
Okay, so then for vertex form, does it make sense to do the same thing and write x minus 6, that quantity squared, is x minus 6 times x minus 6?
Yes.
All right, and then we are going to do some distribution.
Double distribution, Mr. Carlson.
It's true.
And then 2 times x squared is 2x squared. 20, I'm stealing your thunder, I'm sorry.
That's cool.
And then you have 72, and 5 more is 77, just like Ray Bork.
All right, and that is going to be standard form. And then the other thing that we might be able to do is to put that into factored or intercept form, which again, I don't know if we really want to do right now with this particular set of numbers.
I don't think we do. I think getting it to standard form is fine. If someone wants to talk to us about it, by all means, bring it up and have us talk about it. But the other forms, it just requires a little bit more algebra than we've done thus far.
Sure. All right, now we've got to decide if quadratic functions are unique or not, I think.
Well, it says writing a unique quadratic function.
Yeah.
It says George and Pat each wrote a quadratic equation with a vertex of 4, 8. Analyze each student's work. Determine the similarities and differences. The similarity is they have the same vertex.
They do, and I also noticed that they started the same exact way, and it's only the last step that they start to change.
So does this relate to that problem that we said they might want to talk to us about? where you have the point 4, 8 floating in space up here. George's has a negative leading coefficient. That's that -1/4 there. So that's going to look something like this. And Pat's has a positive. So that's going to look something like that.
So those are similar, but also different quadratic functions.
Yes, and I regret my decision to draw those like that because Pat's should be wider. I apologize.
That's okay, it's not to scale.
And I don't think they need us for this. I think they can read this and process this. So if I were they, I would pause it right now and read through. I'll move that over just a scooch. Read through.
I'll move this one just a scooch at the same time.
Those problems and see if you understand what they're doing. And if not, ask us in class and talk to us.
I think that's a great idea. This is a really good way for you to practice using some kind of a resource and then asking for help if you're still struggling.
And I love this page. It does say pause, so they need to pause, but I love this page. So you should pause, but make sure you understand what you're doing before you pause. So all it's asking you to do, it's not asking you to do the work. It's just saying, which form should we put this in? Standard, factored, or vertex form, or none. So keep that in mind. It only asks you which form to put it in. You don't have to do all the messiness to create these functions, but you should pause now.
Okay, now that you're unpaused and you've kind of thought through this, I wanted to just remind ourselves what information each of these gives us pretty quickly. So we got standard, vertex, and then we got factored or intercept. We said that standard is really easy to find the y-intercept and the concavity. That vertex form is really easy to find the vertex, the axis of symmetry, and the concavity. The factored form is really easy to find the x-intercepts, also known as zeros, and the concavity. Are there any that I'm missing for this, Mr. Butterworth?
No, I was trying to process along with you. I think those are the things we wrote down. Yeah, I think we're good. I think that covers them. So like the first one tells us a minimum point and a y-intercept. So the minimum point is also known as the vertex.
So if we see the word minimum point or maximum point, those are things that we could also call a vertex.
Yes. So I would do that in vertex form.
That makes sense to me.
And then the next one has 2, 0, 8, 0, and 4, 6. And my initial inclination is actually wrong because when I looked at it again, I was like, wait, 2, 0, and 8, 0 are both zeros of this function. So that means factored form would be the easiest.
What was your initial inclination?
Well, I saw 3 points with like I do in C. And when I see 3 points, a lot of times the quote easiest way is going to be standard form.
Sure.
It's not actually easy because it's a system of equations.
Yeah, and that's kind of a mess.
But it's really the only, when you have these points, actually, I take it back. Look at these points. We don't even need that. It's because we have 175 and then 450 and 75. So we can find the vertex.
So because we know both of those, we can find the x part of the vertex. And I think that can probably let us use vertex form without too much work.
Yes. Ooh, see, I was wrong again. Look at me.
Ooh, and I noticed the same thing on the next one as well as noticing something else there. That's kind of fun.
Yeah, see, they tricked you because they gave you the same ones on the first two, but then the third one has the same y value.
And the only thing that I can draw through 3 collinear points is a very well-drawn line.
Right.
This, sir, is not a parabola.
It is not. Oh, I thought you were going to write this one. I got this one. Vertex. Nope. All right. X-intercepts. Well, I see x-intercepts, so what should I use?
To me, that sounds a lot like intercept or factored form, because that seems like a pretty good place to begin for that.
Is that the same thing for the next one?
That makes sense. Roots are another word for x-intercept or 0.
Is this their devious way of telling us that roots and x-intercepts are the same thing?
I think it kind of is. That's kind of clever on the point of this book. That's cool. So we said that
That's
both
key
of
for you
these
guys. Those could be called zeros, roots, and intercepts. And often those will be used interchangeably.
factort. Don't
Almost
even
how you spell it,
know.
Mr. Carlson. Almost. Max hits a baseball off a tee that is 3 feet high. Ball reaches maximum height when it of 20 feet when it's 15 feet from the tee. So we have a tee some distance off the ground, and it goes like this.
And they tell us the maximum height and how far over that is.
Oh, that's like you said maximum is vertex. So we should do vertex form.
That sounds good to me. I noticed that all of these are either vertex or factored. I wonder if that's because those are much easier for us to use for the most part, if we have some information.
Well, yeah, and it's also because we don't want to get into systems of equations, and that's really the
That's true.
only reason you would write standard form. What do we got next? What do we got next?
We got to write quadratic functions that include the given points. And then I can't read. If it is not possible, say why.
Oh, okay. So we had the example of this before where they wrote a x minus h squared plus k, and then they plugged in. So they said a x minus negative 3 squared plus 4. How do I figure out what a is, though?
Well, we have another point, and if we think about how points work on graphs, that other point is going to be x equals negative 4, y equals 1. So I bet we could plug that in here, and we get a negative 4 plus 3 is negative 1. Oh, and then the y is on the other side. Okay.
Oh, and then we subtract 4.
Mm-hmm.
So that's negative 3. And then negative 1 squared is 1. So a is negative 3. So I could just go back, since we did a terrible job spacing things, I could just go back and erase this a and write it as negative 3.
I have never seen anything else more beautiful.
You should look in the mirror, friend.
Aww. Okay, so for B, we're also given the vertex and one of 2 different x-intercepts.
So they should try to do this right now. Pause your video and try to do this. I like how we both froze without communicating with each other. That was good. Now, they should be back now. I want to see what you do, because I have an idea, but I want to see what you do.
I have an idea, too. I'm going to do something crazy. And the crazy thing that I'm going to do is going to look at this. And I'm going to say that 2 comma 0 is another point on this function, because I know that my axis of symmetry has to go through my vertex. Was that the crazy thing that you were going to do?
Yeah, you stole my thunder.
Yes.
But I can do it a different way. So you do it in that way, and I'll do it a different way.
Okay. So I'm going to work on the right side of this line. And I've got a times x minus 2 for the 0 I just created, and x minus 4 for the other 0. I'm then going to use my vertex for my x and y. So negative 2 is equal to a times 3 minus 2 is 1. 3 minus 4 is negative 1. And we end up with negative 2 is equal to negative a. Hey, that means a equals 2. Y equals 2, x minus 2, and x minus 4.
Like it. But you could have also, since you're given the vertex, you could have just done the same thing we did over there and said y equals that a x minus h thing. So a x minus 3 squared plus, now it's minus 2. And then plug in the x-intercept. So the x-intercept was 4, 0. So 0 for y, 4 for x. 4 minus 3 is 1. Squared is 1. Except for when students say 1 squared is 2. That's like one of my favorites. But that's 1. And then add 2 to both sides. So we'll have 2. Hey, I got a equals 2 also.
What?
So then my
Oh,
equation is 2. Will we always get the same answer, Mr. Carlson, with the 2's?
I think if we're doing the same problem but in different ways, we should always get the same a value.
But our
That's cool.
equations look like wacky different.
I mean, I guess we could multiply them out to get standard form, but I think that's for students to do on their own and have fun.
That sounds great. And C is an extension problem. If you want to try it, go for it. Feel free to talk to us, but we're not all going to do that. And I have good news. This is the last problem because everything else beyond here is extension. If you want to do it, if you are prepared for it and you want to try it, we are happy to support you with it, but we're not going to do it in this video because it would take a little while. But we're happy to support you in it, so let us know. This question says that Wilhelmina, is that how I say that?
Sure. Wilhelmina.
Says she can write a unique quadratic function given only 2 points. Is she correct? And guess what? That says class. So that's something for you to think about. And maybe agree or disagree, give us an example or two.
I wonder if every time we see this symbol, like an idea is you should agree or disagree with this person before you talk about what you're doing there.
Oh, is that what the thumbs up, thumbs down is?
I think it probably is something like that. I think it means decide if they're right or wrong, but
How good of them.